training. And today, our topic is plan and implement security for public access. And our speaker is Imoh Etuk, and I'm the moderator. So I would like to talk briefly about our speaker. So we have our speaker today, Imoh Etuk, is an MVP and a Microsoft certified trainer. When I say MVP, MVP means Microsoft Most Valuable Professional. So we have a Microsoft Most Valuable Professional in our midst and a Microsoft certified trainer with 11 years of experience in the IT space. It's not easy. I want to see us give a round of applause for our amazing speaker. The consistency and all is not easy. And he's also an experienced technical architect. See who we have in the house with experience in cloud and on-premise infrastructure management, system administration, DevOps, first-hand technical support and project management, with extensive experience in designing and implementing workloads across private and public hybrid cloud solutions. He's also a strong team lead who focuses on client-facing responsibility, working closely with customers to align technical solutions with their business needs. He's also an adept technologist who is passionate about solving technical problems for customers, and he have an excellent team leadership. I've been privileged to attend the training that is hosted by that Mr. Imoh Etuk was the person that facilitated that training. I could tell you that I learned a lot from that training, and he's a kind of person that if he's training you, he breaks things down in a way that everybody will understand. Like this. In addition, Mr. Imoh also enjoys crafting detailed technical articles. If you check his LinkedIn page, one thing I know Mr. Imoh for is that anytime there's any update on Microsoft Cloud infrastructure, he's always one of the first to post it on his LinkedIn page. So we can also follow him on LinkedIn and put a like on his articles. And he also tries in making complex cloud and DevOps concepts accessible to diverse audience. And also, he contributes meaningfully to the Microsoft Azure and AWS community through speaking engagements, panel discussion, and virtual trainings. Also, we also have him here, meaning it's also contributing to the Microsoft Nigerian Security User Group. So this is the best time for me to introduce our speaker. Thank you, Mr. Imoh, for joining us today. You have the floor, sir. Thank you, sir.
That introduction was too much. So thank you, Emmanuel, and it's a privilege to be the speakers for today's section. And thank you very much for having me. Welcome everybody, welcome all the audience. And I'm happy to be the one to deliver this section to you. Can you all hear me?
Loud and clear.
Yes, sir.
So
we can hear you loud and clear.
Yeah. In my own structure of delivering sections, I like participation. I like people to participate. I like you to take part. That's the only way I can understand that, oh, you are following along. So as I'm going to be diving in, I would like you to make use of the chat section. The moderator is going to bring up your chat if I'm missing it. And if you have questions, raise your hand and ask. I will give you the audience. So just as Emmanuel has introduced, my name is Imoh Etuk, and he has said everything that you need to know about me. You can check me out more on LinkedIn, and I think that's the only place I'm very active. So I'll be sharing my screen right now. So what we are going to be looking at is plan and implement security for public access to Azure resources. This is a very broad sections and an area of coverage as we're going to go into. But before I start, I don't know if this section is recording. Okay, it's recorded. It's being recorded. Okay. So I would like to know, I know that we are all coming from different backgrounds. A lot of us are coming from maybe the infrastructure aspect of the cloud, the platform as a service, or the software as a service. But I would like just to weigh the audience to really understand where we are coming from, because this topic cut across a background in networking, a background in the understanding the system procedures when it comes to iOS. So we need to understand if you are just starting up or you are being experienced the cloud space. Because for you to succeed, I usually tell people in the cloud space, you need knowledge of basic networking. You need to understand some of those basic things like all those. You need to understand the ISO model, how it operates. OSI model like that is from layer 1, which is the physical layer, to the application layer, because most of these things we are going to talk about today is going to be boiling down to the layer 7, which is the application layer, transporting data across the HTTP and HTTPS. So and TLS as well. So as I move on, I would like you to share some of your experience in the chat. Oh, I have experience with the OSI model. I'm familiar with from, I think, the transport layer, which is the layer 4, and also layer 7 is going to be our point of focus, and also the firewall and all that. So diving into this topic will give us an understanding to understand the aspect of security, securing public access. When we talk about public access, it simply means people directly from the internet, traffic routing from the internet to your secure infrastructure within Azure space. So how can you now restrain or control access? Some of the things we are going to explore. So we explore TLS. TLS, formerly known as the SSL. It has changed from SSL to TLS, transport layer security. Before now, it was specifically known as the secure layer secure layer security, something of that, SSL. We also have Azure Firewall, application gateway, WAF, that is web application firewall, front door, CDN, and DDoS protection. So finally, we are going to learn how to deploy and protect our infrastructure. So moving on with me, if you look at the first topic in this is going to be transport layer security, TLS. So now on Azure, TLS offers you a way of securing access to your application using the transport layer security. You start with a strong authentication. It offers strong authentication. When we talk about strong authentication, in the sense that messages that you send that travels over the internet uses this protocol to safeguard the delivery of that data. Have you ever wondered when you send an email, if you send an email that, hi Imoh, how are you doing today? From your own computer, maybe from Nigeria, and it delivers to me the same message without changing. So why is this data protected? So because the data is encrypted when traveling from one point to another. And TLS operate at the layer 4, transport layer. That's the OSI model. So you operate there and also operate a little on the layer 7 of the OSI model. So now it also offers you ease of use. In Azure, you can simply just deploy it, and the management is very easy and all that. So another one is you can also have access to message privacy. Like I mentioned before, it encrypts your data for confidentiality reason. Gives you that confidence that whatever you send out won't be modified along the road as it's traveling. So the interoperability, which is powered by OSI model. The essence of OSI model is to offer us this interoperability between systems. OSI model that stands for Open System Interconnection Model, is a conceptual framework we use to understand how data moves from one computer over internet to another, over network to another. So it works hand in hand with that. Now, aside that, we'll move on to another one. It also offers us a message privacy and integrity. I've spoken about that. Okay. So you also see that your message is also encrypted over algorithm, the SHA-256. It's also encrypted as well. So you can also enjoy what is known as perfect forward secrecy. Perfect forward secrecy is a protocol that also operates while your messages are transporting from one product to another. So in overall, implementing TLS on Azure enhances security for Azure App Service and API management. Now, moving further to another point, where we are going to be talking about Azure Firewall. Now, Azure Firewall is a very powerful tool, powerful service that offers us effective threat protection for your cloud workloads running in Azure. You can see that with Azure Firewall, you can simply just restrict access to some certain website. You can use the FQDN filtering, that's where it comes in. The FQDN, fully qualified domain name filtering. Assuming you work for company ABC, and that company ABC now, they want to restrict access to some website, like they say everybody must visit maybe bing.com or microsoft.com, and no other website outside these two websites. So Azure Firewall offers you that the ability to create classic or Azure Firewall policies. We have two policies. When we're going to get to that place, we are going to see how they work. So you can create either the classic rule set to filter some URL that you don't want your employees to visit or your users. It will automatically block. And that can happen. You need to route your traffic from the VM that you are using. Let's assume you have remote user who gain access to your work VM through a jump VM. How many of us understand what a jump VM is? So a jump VM sometimes serves as a route leading to the main server that has your workload. Why jump VM is useful is that if there's any vulnerability, the bug can stop at the jump VM without getting into the main workload VM. So Firewall helps us to filter this traffic through traffic that comes from the user PC, end user PC, through a jump VM, who serve as a jump box. If you're familiar with networking terms, that we usually call it jump box, then it could be a virtual appliance, maybe a virtual appliance. It could be something like that stand in the gap, that grants you access. Now access will be regulated within this flow from the jump VM to the main VM that has the workload. So that's what this one also works. Now, network rules. You can filter traffic based on IP addresses and box and port numbers. Like majorly, do you understand the concept of DNS, how DNS works? Anybody can say something about that in the chat. So DNS is known as the phone book. I just call it phone book of the internet. What does it do? It helps us to translate IP address into a fully qualified domain name. Or every website that you're seeing has an IP address behind it. Without the IP address, it can't work. And computer only understand IP address. It does not understand www.yahoo.com or microsoft.com. So what it does is to help us to, so the port number, which is port number for DNS is 53, port 53. So you can actually filter traffic based on DNS port number 53 and route it. Then how can you now effectively protect your VM from encountering? So you need to route traffic from your VM private IP address through the firewall. So from there, firewall will track all the traffic, filter them according to the rule that you set. Now, outbound SNAT. Outbound SNAT means it helps you to securely track outbound connections to your network. All the outbound connection that's in traffic that goes out from your own end to the internet is also tracked. Then it also offers you us the inbound DNAT. Now, DNAT is destination NAT, the destination network address translation. It helps you to regulate inbound traffic that comes in. So firewall operates at layer 3 to layer 7. It's connectivity policies that integrate with firewall manager. Azure also have firewall manager. Firewall manager offers you a centralized place for you to manage firewall policies in one place without having to jump. But firewall manager is necessary when you want to use Azure firewall policy. Remember, I mentioned that Azure firewall policies comes into two. We have the classic rule and the policy. So policy is the one if you want to manage several firewall instances at a time. But if you are just now we are going to create just one firewall, so we don't need policy. We just need a classic rule to manage what we need to do. So I'm still expecting some questions if you have. Now, how can you now plan and implement an Azure? Now, okay, let's speak about Azure Application Gateway. I don't know if we are clear with how firewall works. We are still going to do some practical around that. So web traffic, let's first of all differentiate between firewall and application gateway. Now, it is not possible for you to directly secure access to your app service with Azure Firewall. So Azure Firewall is effectively used for securing access to Azure virtual machine, while Azure Application Gateway serves as it's also known as Azure API. It serves as the one that you can use to secure access to your web application like that operate with the app service. But then you can also secure access with for your app service using Azure Firewall, but it has to be routed through a private endpoint. So that is majorly some of the difference, some of the stuff we need to understand. Now, Azure Application Gateway offers us a lot of benefit. We filter web traffic and also offers us enhanced security when it comes to protecting our web application. It offers us something like SSL termination. SSL termination allows the application gateway to decrypt incoming SSL or TSL and understand traffic over the gateway level. Now, this helps us to reduce workload from the backend server. Now, when you are routing traffic, when you are using application gateway to control access to your server, what are you simply doing? It means access coming from the user will land at the gateway. Now, WAF will be deployed into that gateway. What is this WAF? Web Application Gateway, Web Application Firewall, which I'm going to see talk about later in this course, in this section. So when you deploy an application gateway, you now deploy what's it called, WAF, Web Application Gateway, to stand in the gap in filtering traffic. And web application gateway firewall operates. The rule you need to create is called the listener rules, listeners, which works operate at on HTTP/HTTPS protocol. So it means that all the traffic being sent by the user to your web application gets to the listener level, and it will listen at that place. The WAF will operate and check if the rules that were defined at when you were setting up the listener policy matches with the user traffic. Then it will now allow access to get to your backend servers. Mind you, backend servers could be a server hosted in Azure, or it could be a server on your own premises or anywhere. So that's how they work hand in hand. Oh. So what is the what yes, for the yeah? Can you hear me? Okay. You have a question, right?
Yeah, sorry, I think the person mistakenly unmuted. I have muted the person.
Okay. Secure socket layer. So now we have this, okay, someone has helped me to post those acronyms. Okay, I left the chat, don't mind me, I'm pressing the screen. So now we have, one of the things it does is that it offers us that SSL termination or TSL. Like I said, is now more of the transport layer security, that is TLS. Now, another like some use cases for SSL termination, in some, there are some e-commerce website like the likes we have popular one, Jumia or other one. We see that if Jumia wants to offload the SSL processing from its backend server to improve performance, the application gateway can handle the SSL decryption by freeing up the backend servers to focus more on the application logic rather than cryptographic processing, or maybe being the one handling everything. So our application gateway does that, and it works a lot for e-commerce website where you have a lot of traffic coming from a lot of people, maybe mostly festive period and all that. So it also offers us the section affinity. Now, in section affinity, as the name implies, it will enable application gateway to route subsequent requests to the same user section. How do you mean? Okay, what I mean now is if you have a system that you regularly visit, the backend will mark you. It will use section affinity to learn your activity and mark you and present you with the same section data instead of frequently changing it. So this actually help a user to maintain a single section state. So whenever they visit your application, they have that same experience. And I can tell you that it also very helpful for making user to have the same experience, so they wouldn't be suspecting anything. So another one, the use case for section affinity is if you want to maintain a section state like authentication token to a specific server, we can see that in banking application like mobile app for banks, that works very well, and you can use section affinity that the user subsequent requests are routed to the same backend server without changing. So I have server 1, 2, 3, and I want user 1 to go to server 1 regularly, and I can use that section affinity to track that. Now, another one is the URL-based routing. Now, URL-based routing is a feature that allows routing of traffic on a URL path base. Okay, now, if you go to the university portal to register for course, let's say a school, they have opened for admission, and you see that, let's say a university like a University of Lagos, unilag.com, or okay, yeah, I think it's unilag.edu.ng /admission. There will be another one that is called like /registration. So those are URL based. Now I can use URL-based routing to ensure that students are routed to the right URL at any point in time without changing it. Or what if I'm operating stuff like a Netflix or a video stuff like that, or I want to make sure my user are utilizing static contents like images and all that. I can also create a path-based URL and based on maybe /images, maybe being stored in my blob storage account. So user just goes straight to that and access those images. So that's how it works. So URL-based routing is simply very helpful when you want to have maybe an institution like school that is trying to route admission and all that, and offers you a universal portal that enables a student to register and track whatever they are doing. Now, we also have another one, which is a feature of Azure Application Gateway, round-robin load distribution. So what does it mean? So round-robin load distributions uses an algorithm that distributes incoming traffic evenly across multiple servers. Like now, for instance, I can have maybe server ABC, and I also have user 1, 2, 3. So now it will help me to, if I want to say, okay, I want my traffic to go evenly without having to overload one of the servers with too much traffic. I can make sure that user 1 is routed to traffic from user 1 is routed to server 1. Traffic from user 2 to server 2, traffic to user 3, like that. Now, when you hit the last one, like if we get to server C with user 3, who is the last user, it will start again all over and route accordingly without missing that track. So Azure Application Gateway, I don't know if you can give me another name for Azure Application Gateway so far. Anybody don't understand? On Microsoft Azure, what can you call Azure Application Gateway? So I think we can drop your answer on the chat section. So what does it do? Azure Application Gateway, as we've been explaining since, enables secure and scalable web traffic management. Now, another one is that enhancing security for your workload is that it can offer you web application firewall, which I said, as I spoke about it before. So they work hand in hand. A WAF is a feature that provides centralized protection against common web vulnerabilities. Such a vulnerability could be those ones that have been marked by OWASP top 10 security, and it includes like a SQL injection, cross-site scripting, and all of those things. So this is very useful when you want to majorly focus on government portal, government controlled, regulated portal, like the likes of the government portal we have in the country, like the likes of NIM or all those stuff. So you can use this to achieve that. You can use the web application firewall to achieve protection against that. So it also offers you centralized SSL management. Now, application gateway allows you to allow centralized storage and management of SSL certificate. You have all the certificate in one place and can manage with application gateway. Now, use cases for this one could be maybe a company that has a multi-tenant operation and that serve like a software as a service application to users. You can use that one to achieve to protect traffic within such scenario. So I don't know if you have any question, you can stop me and ask. So moving further, we'll talk about plan and implement a web application firewall, which is the WAF I've been talking about. So a WAF solution can react to security threat faster by centrally patching a known vulnerability instead of searching for each individual web application. So now, as I mentioned before, we have a cross-site scripting as part of the thing that WAF can help you protect against. Cross-site scripting is one of the OWASP top 10 security vulnerabilities. You can read more about, let me look for the link. And I don't know, let me check if anybody has posted that. Okay. Please do, okay, there's a question. Now let me share link to Web Top 10. So you can okay. Found the link. So you can learn more about it on that link. So WAF will help you to protect against that. And it also help you to protect against SQL injection, defense against SQL injection. You know, that this injection stuff that can come in and destabilize your whole database and all that. So it also gives you custom access control. You can tailor your policies based on what you want. You can configure policies and associate that policy to one or more application gateways for protection. Like I said before, you have a lot of application gateways that are created. So each of the policy, which is based on the listener policy, that will listen to traffic being sent by the user and now understand if it matches the rules before passing it to the backend server that hosts the workload. Work with the Azure front door, work with application gateway and Azure CDN to enhance security within your environment. I'm going to send a link. There's a link here that you can go in and learn more about WAF. So let me drop that link in the chat. Let me show you seconds. Okay. So you can learn more about WAF, and because the material is not exhaustive in this course, you can learn more on that link. Now, moving further, we'll be talking about Azure Front Door and Content Delivery Network, which is CDN. Now let's understand, first of all, how front door work and how CDN works. Both of them are global a global protocol that helps us deliver content closest to the user. Like people that stuff like Netflix, all this video, most of the video streaming platform make use of CDN to cache content quickly to the user. But now, how do you now do it? How do you now know when to use front door or CDN? Now, CDN and front door is used majorly for dynamic application or API apps. Now, if I'm developing an app that is going to serve users via API, I will need to use Azure front door. But if I'm just building a static content that the user needs to just access videos, images, but I need these videos or static content to be delivered to the user faster, I can go up for CDN. So note that two of them are global content delivery system. I can deliver system with content faster to users, but there's a way you use them. You don't use a WAF, use a front door when you are dealing with an application that has to do with dynamics delivery of content, dynamic application or API apps. While you use CDN when you're delivering web content, like static content to users. Now, both of them operate at layer 7, global routing. But then I think prior to this stuff, to this time, CDN was operating at layer 3, layer 4, transport layer. It was, I think, recently, Microsoft made some changes around that by merging everything together. So I think now both of them operate at layer 7. Now it also offers us, it helps us to accelerate application performance with any cars and split TCP. It offers you also URL routing, base routing and section affinity. Also help us to handle multi-site hosting, content, custom domains and certificate management, application layer security, WAF. Also offers us URL redirection and URL rewrite. Protocol like IP version 6 and HTTP to traffic also help us to demonstrate that. So now, note some of the key things you need to pick here is that Azure front door operates at layer 7 or HTTPS layer. Then it uses Anycast protocol with splitted CCP. And both of them operate on Microsoft global network for improving global connectivity. Now, based on your routing method selection in the configure, you can configure Azure front door to route your client request to a fastest and most reliable application backend. depending on what you want to do. Like if your users are majorly, I think a state in the United States that really are focusing on content. Is it California? Where we have all the headquarters for video delivery network or application like Netflix so that's where majorly people route to. So another one is I don't know if you have question on this and how they work. So now another one is the last on the list, I think, is the Azure DDoS protection standard in this case. So we are going to be speaking about standard. I think we have premium. Yes, premium is there. So now Azure DDoS protection offers us a comprehensive protection and defend against layer 3 and 4 attack. It also offers us scalable solutions, offers network and IP protection. So with DDoS, you can protect users. But then let me talk more on DDoS, distributed denial of service. That's what it means. So how does it operate? It means that if I have one server and I have users, and this server is constantly delivering legitimate content to users, to non-users that are legitimate. Now there will be an attacker who is somewhere creating a bot service that will be shooting traffic to overwhelm the server as to not to deliver content to legitimate users. So when the server is overwhelmed, of course, it will break down. So that's how DDoS happen. With Azure DDoS attack, DDoS protection, you can use that. You can prevent such attack. So now let's look at the architecture diagram. Now we have application gateway. We have a user, we have the internet, which is operated on the public IP that traffic is being sent to your web application, to your application. Now, if you look at it, we have web application firewall. Behind that web application firewall, we have rules that we are created. Now, remember, you use application gateway to load balance traffic. Now, this should give you the idea that application gateway is also known as Azure load balancer. So now it is when traffic that comes into this application matches rule that you have defined using the web application firewall, that the application gateway will now route the traffic to available web app service that you have. Now you have the backend server, which stores the logical information like database and all that. So it is when the rule matches that you will now forward traffic to those people, to those guys. And what are you using the DDoS protection for? To protect against DDoS attack. Of course, so that's how this works. And you need to operate, this has to be in the VNet. It has to be deployed into VNet. But in this case, you need to disable direct public access. If you want to introduce Azure Firewall in this case, you need to route traffic through a private endpoint. So if you have a question, I would like you to ask before we go into demo section. Okay, if you do not have question, I think I should ask questions around what, let me check. I can see questions to ask us. Do you have any, like, do I have knowledge check question? Okay. Oh, now I want to drop resources that you can learn more. It's not, learning doesn't stop here. You need to go and explore more. So I will drop the link for us in the chat now that has huge content. Oh, Emmanuel, you have hand raised.
Yes, sir. Thank you very much. I have enjoyed the section so far, and I like the way you explained Azure Firewall Manager. Please, I don't know if you can just help us explain on Azure Virtual One. so that we can just understand how it works. So,
Okay. Azure Virtual WAN, as the name implies, is meant to protect remote users. Remote systems, like, for instance, if you have an office in Nigeria, you have users strategically located and working remotely, you could deploy Virtual WAN and share the point protection to end user systems. So while firewall can protect your own main system, like the workload server that operate in a fixed environment like the HQ headquarters, you can use Virtual WAN to protect users in transit. Yeah, I think I will have to drop a link for you to learn more about how that works. But I don't know if that my response is clear to you.
yeah,
Yes,
it's very
response
clear,
about that.
and I like the
Okay,
scenario you used. Thank you, sir.
you're welcome. So do you have any other question? I have some links I've shared in the chat, so you can actually explore more on what we have touched. Okay, so now we want to work with a VM routing and securing VM traffic via Azure Firewall. We will also, one of the ways to also protect your VM. Okay, I want to differentiate something now. Anytime you deploy a VM on Microsoft Azure portal or any means you use, we use NSG to regulate inbound and outbound traffic. And it means that VM that we deploy, we must have attached public IP. Best practice is that when you deploy a VM, do not attach public IP. Access to that VM should just be restricted by default. You can only do that when you need it or when there's a need for public IP. One thing I always advise people, if you are routing traffic to public traffic directly and to a VM that you have attached public IP address, you need to use Azure policy to constantly either disable or disassociate that public IP address from your workload when not in use. Microsoft has built-in policies you can use to work around that. And you can also decide that if you don't want to use public IP, route your traffic to Azure Firewall. Let the Azure Firewall handle the regulation of whoever has access to your VM or whatever. So now, here in the lab, we are going to see how we can route and secure VM traffic using Azure Firewall. I will go into my Azure portal now and see how that works. So let's open to the portal. Now I have my portal open. And here, what we are going to be deploying is, or what we are going to be working on. We are going to see how we are going to set up like I mentioned during the explanation, we are going to set up a jump VM that will help us deliver content from a user or traffic from user into the workload system that is secured with the Azure Firewall. We are also going to see how we can configure the DNS and then route traffic to the VM, to the workload VM through Azure Firewall. Now, the first thing first we need to do, we need to deploy the resources that we need. And because we have a lot of resources to deploy, we cannot go through portal alone to deploy. So this is a template that being already prepared, a bicep template that we will use for the deployment of this stuff. But before we do that, we need to, we all understand that for every resource we deploy on our Microsoft Azure, it must be deployed into a resource group. So we need to, first of all, get our resource group set up and then begins to deploy the resources using this bicep template. So we're going to use the normal, first of all, let me authenticate to my open Azure, Azure so that I can select the certification, the this thing I need, the subscription I need. If you have questions, feel free to ask. Okay, so we are going to be creating the resource group using the command, the CLI command, SZI and SZ group create. The name is we are dealing with MS security user group, so it should be tied to that. So this will deploy resource group for us. So we have our resource group created. Now let us deploy the template file. Before I go ahead to deploy the template file, let us explain it and make you to understand how it works. Now what we need to do, all the basic param file have been defined here with the names of our resources being mapped to the param file. And the param file is referenced in the main template that has all the code for deploying all the resources. So this one is to allow Azure load balancer inbound traffic. Remember, Azure load balancer is like application gateway. Now it's going to also define denied all inbound with, of course, when you see the priority number, the one with the lowest number take a priority before the one with the highest priority number. So after that, it will deploy NSG and also allow traffic at, let's check for, there's a point I need to emphasize. Now we have the server called Jump Server. Of course, it has the public IP address. And if you look at the template is referencing public IP address and with an API version 0.12/2018. Now the location, and we are utilizing the basic plan, basic public IP. You know, of course, public IP is regional in nature. Now we are not going to reserve our public IP address to ourselves. That's why the nature is dynamic. Now we also have the address namespace. And we also have the CIDR range to be /24. If you observe, they are in the same range, but just that they must not overlaps with each other. That is why you see different a bit. So we also have the workload subnet. Workload subnet that will be attached to, we are going to deploy the workload server to the workload subnet. Now we also have the jump server, which is the jump host or the jump router, anything you can call it, subnet. We also have the VM side of it. We have the VM size to be standard DSV version 2. And the data center we're using is 2016. Now on your own, you can change it. So we have all the disk storage, file storage to be premium LRS. That is a locally redundant storage. Then these are the VM min and password. So these are how the basic file is structured. So now we go ahead to deploy it, and you run the AZ deployment file. I don't know many of you have deployed what's it called, basic file before. Deployment group. The resource group is MS-security. -rg. In the name of the template file, template.file main.bicep. Parameter file has to be referenced as well. Bicep param. So yeah, we reference everything within this command, and it's going to deploy all the resources to the portal. Let's see. Template, did I make mistake with? Oh, I didn't spell template very well. Template is supposed to be A-G-T-E. So this is going to help us in deploying the stuff. We're going to just wait a bit and make sure we observe that it works. Did I make mistake with this MS? Could not be found. Okay, let's first of all verify that that resource group was created. Oh, the second one was underscore. So let's fix that. Second command was underscore. And press. So while that is being deployed, we can just wait and see. Let me look for some question and ask us, because with what I explained, I think we should be able to understand what I just explained now. So why will you now implement transport layer security in your Azure application? If you are working in an application and the user or the organization you are deploying to wants to implement TSL, why will you do that? What is the purpose of implementing TSL in an Azure application? The question is on the chat. Now, we can also get to understand how Azure Firewall contributes to the security of the Azure infrastructure. How does it work? So from what I said, it helps us to lock all the inbound and outbound traffic according to firewall policies, all the rules you have defined. So a lot of things, yeah, I think this track is bordering around the AZ500 for those of you preparing for the exam. So you need to familiarize yourself with the learning parts, which I sent some of the links in the chat. Now the resources are being deployed. So now we have our resources. If you refresh the resource group, you should have all those resources here. So the next step now will be to deploy our firewall, Azure Firewall now. So go to the portal, search for firewall. Here we do not have anyone, just click on create, select resource group, give it a name. The name could be anything like AZ Firewall, MS Security. So I will leave it at this. I will not map it to any zone. The basic this thing does not track or protect. Now let's understand the premium plan. Now the SQL, the SKU for firewall, we have the basic. Basic only do the normal detection, pointing you to basic detection, but does not protect, does not filter traffic. Now, the way standard work, standard will help us to detect and protect, or it will help us to prevent, but it will help us to detect, but does not prevent. Remember, the basic will alert the user, will not alert the user to only observe and give you some sign. But this one will help us to detect, and also I think it's majorly for detection. That's the standard. And it's basically for test environment, not for production. Now we also have the premium, which do the two work, like detection and protection. So when you create this, depending on what you want to do. Now here, if you observe, we have used a firewall policy to manage this firewall. That is, if you want to manage a volume of Azure firewall, you can use the policy. But here we are just managing one. So we need to use just the classic rule. Now we have a point where we need to map it to our virtual network. So we need to choose existing virtual network. Now, do you know why this thing is a prompting error? Because the enable firewall management NIC is selected. How this one works is that if you want to use forced tunneling to manage traffic to your network, you need to have a subnet that's known as Azure Firewall Management Subnet. And now, how do you need this? When you want to have a certain production servers that is directly owned by management, that manages management data, that when you can now use this particular scenario. You want to map a particular network interface card to a particular subnet that is controlled by firewall for management workload. But here we are not doing anything management workload. So I'm going to disable this guy. Now I will need to route it to the firewall needs to have its own public IP address. So we need to create a new one. I'll just call it FW PIP. That's firewall public IP. Now, the next one will be, okay, I think another thing you need to understand is that
Excuse me,
in
sir.
our
Please, sir, can you help us increase the resolution of your screen? Someone is complaining that.
okay.
Thank you, sir.
Apologies for that. That is the font size, right? Is it clear now? Is it big? Is it more visible now?
Yes, sir, it's
Please,
fine, sir. It's fine, sir. It's fine, sir.
Okay, can you enlarge it? I've been straining my apologies for that. I didn't say what is different between MFA and say, oh, both has to do with security. Okay, now there's a question here. Okay, so the difference between MFA is majorly for it's supposed to be functioning as password, MFA, but it's just that it has to do with what you know and something you have and who you say you are, which require additional layer of security, proving yourself with either your fingerprint to access application. To access application, not to protect data that application carries. Now, I think someone is unmuted. Hello, can you mute yourself? So now, someone is asking the difference between MFA and TLS. TLS help you to protect data that the application has. The traffic, the data that you transport, that you send across the internet from your application. That's what it help you to encrypt the data. While MFA gives you additional layer of security to access and maybe a portal, a web platform or application. I don't know. I think that should that helps in clarifying that. So Now we are going to deploy, we are going to go here, no need for tag. We're just going to deploy it. So from what we deploy, we have VMs that have been created. We have 2 VMs that have been created, the jump VM and the workload VM. And we have our test firewall VNet, and we have the 2 subnet that have been created for us. So while that, it might take a while for it to finish deploying the firewall. So the next thing will be to create a route. We need to route our traffic through the firewall that we just deployed now. So let's finish because we need that. So now let's go to, I think we can create that route without having to wait for this. Search for the route table. Okay. Search for route. Create one route table. I'm going to use the same this thing. I'll just call it FW route. Propagate gateway route. Yes. So review and create. Let's check if the firewall has finished deploying. Refresh this guy. Okay, the firewall has finished deploying. Now the route has also finished deploying. Oh, it's still in progress. Now what we need to do is to create a route table. This is the route that we just created. So we have to associate this route to the subnet, the workload subnet. If you observe in this place, go to test VNet, go to subnet. We have 3 subnet. Remember, your firewall subnet must be named as Azure firewall subnet. Otherwise, it will not work. That's the naming convention for Azure firewall. It's for a subnet that is attached to Azure firewall. Just like I mentioned of Azure firewall management subnet. If you use it to manage force tunneling, you need to add management to the name of the subnet before it can work. So now we are going to create and we are going to associate this route to the workload subnet, which is this guy with this IP address, private IP address. So in this place, yeah, we associate it to that. So it means that if you observe, the workload subnet is the one being associated to our VNet, our VM, our workload VM. Look at the workload VM. Go to, if you check through here, so this is the where you get to know the association here. So we have associated that. Now let's add a route. Now you can call this one FW routing. Call it like this. So the destination will be an IP address. And where are we routing it to? We are routing it to any network. We are opening it to public internet. And public internet, you route it to the default and any cast. Now route it. Now the next hub type will be the virtual appliance. And this place will now carry the private IP address of the virtual machine, of the firewall. So let's check for firewall private IP address. Open to firewall. You're going to see the private IP and route it there. So now what we are going to, how do we now say, okay, let us protect our, let's protect the, okay, now let's do something. Now let's go to the jump VNet. If you observe the workload, the workload server doesn't have public IP address, but the jumped VM has a public IP address. So now what we need to do is to go into the jump VNet. Let's sign into the jump VNet. You can either just click connect, download the RDP, or you can use the default RDP from your server and now connect to it. So which I'm going to use just from your system. I have my RDP client. So I'm going to sign in there. Remember our workload, our password and username were defined in our file. Let me fetch that out. Local, I mean, I'm entering into the JUMNet VNet. Public IP. Okay. Local, I mean, is the username. Password is. I want to sign into the JUMNet VNet. Okay. So while that is being logged in, now I'm within the JUMNet VM. Here we are going to privately access the work server using the private IP address of, let me do like this so that you can see where I'm going to. Teams has this stuff that blocks. So we are in here in the private, that's the jump VM that has the public IP address. I'll just minimize this, go back, pick up the private IP address of this, of the workload VM .4. So go back to the VM and open this, open this thing and sign in. You can also sign in directly. There's a command you can use by running the run command and then using this command /v-server -work, because the server name is work. So from here, you can also enter it through like this, or you can use the private IP address. Now it will try to connect to that server. Okay, I'm coming. Let me set up the firewall first. Maybe that is actually going to this place. So setting up the firewall rules, we need to add a rule that says that, okay, that we need to restrict access to firewall to a certain website using that firewall. So let's go back here, open to our firewall. So under rule set, remember I chose classic. I didn't use firewall policy. So within here, We have the NAT rule collection, we have the network rule collection, we have the application rule collection. We want to restrict access to certain websites. So we go with the application rule collection. So adding application rule collection here, we have this. You can use app collection. Any name you want to use, Osonuga works. Collection 01. So the priority is 200. The condition is allowed. Now I want to explain about FQDN tags. You see this place, you define your name. Name could be anything. It could be allowed FQDN tags. Now the IP address would be the private IP address of the server, of the VNet I want to show. Now, how does these tags work? We are not using tags. Let's say you want to control Azure backup of your VM using firewall. So you can actually add a tag to it. So firewall will now control any backup that happen. Now, okay, let's assume for those of us that uses Windows and want to regulate the Windows update, all the Windows update cannot work except that being tracked by firewall. So you can actually select Windows update. So virtually everything you want to do. Those of us who are also working in Office 365, SharePoint, you can also add a tag to track activity there. So that's how these tags work. We are not going to use tags. We are coming to target FQDNs. So here we are going to say allowed web access. Here, IP address is what we want. The source will be what? Let's go to, if we check through, the source will be the subnet of the workload server. Let's go to workload. Let me filter this stuff. Let me filter subnet. Okay. So the source will be this guy. So pick this. That is the workload subnet. Let's see here. And we all know that when you are dealing with a website, anything like web URL, they are simply operating at layer 7, and traffic is transported using the HTTP or HTTPS. So here we are going to route it to HTTP 80, port 80, then we use some command to separate them. We route it again to HTTPS port 443. Remember, the protocol for HTTPS is port 443. Now we want target FQDN. This is the only FQDN, the website that is going to be allowed access to. We now said, okay, let all the users go through bin.com. Only bin.com can be visited on that server. If you try to fit the other one, it won't go. So once we do that, we just add it. That the spelling of bin. Oh, yeah, okay, bin is like that. So it will update the rule. Okay, so now you go to, I think we are still following, or are we still there? Okay, any question?
Yes, sir. We are still here, sir.
Okay, what is the question?
Yeah. So the link to the bicep, the Azure bicep, sir. Please, can you help us drop it?
Okay, let me zip the file and send it as a zip file to this chart.
Oh, okay, sir. Thank you, sir.
Okay. So compress to zip file. Okay, so I will drop it now. Now the rule should be, oh, it's still updating. It might take a while. Okay, let's just bear with me. I can't send attach on the Teams. Why? All right, Emmanuel,
Okay,
maybe
sir.
I'll pass it to you. Let me pass it to you on WhatsApp so you can send.
Oh, okay, sir. Okay, sir. Thank you, sir.
Okay, so the rules is still updating. a minute. So now, while the rules is still updating, let's configure a network rule that will point to DNS port number 53. If we're going to do that, let's quickly drop this. Okay, so link, that is a bicep file. You can check if you have access to upload it to Teams. I just send it to you, Emmanuel.
Yes, sir. Thank you very much, sir. I will drop it on the WhatsApp group. So everybody will have access to it. Thank you, sir.
Okay. So now let's save this. Let's update the network rule. That is the network rule collection to control access on port 53. Here we call it NAT NT dash collection 01. Port allow the priority number 200. Now we have another thing we need to also understand is that we have service tags. How does service tags work? I want to route traffic to a particular Azure service. I want to control, just as we have the AQDN tags, you can also control traffic based on that. So these are the endpoints. But now we need to do IP address in this case. And the name could be allowed IP port number access, anyone that works. So protocol here, protocol would be UDP. Now, another thing I like to implore people is to go learn this protocol, learn about protocols because they are very, very helpful. So the same private IP address, that the subnet for the workload workload subnet will be attached. Now, what should be the destination IP address? Okay, I want to explain something to us. We have publicly known public IP addresses that help us they serve as a global IP addresses. So now, and those publicly known IP addresses are there on the public internet for anybody to use, instead of having to restrict to a particular private IP address. Now, let me explain something. A DNS, now, if you want to have, I think Azure does not directly support some of these, like public.com, or it does not support maybe Google DNS or whatever. So we need to route it through a non-public IP addresses. And those public IP addresses are there in the public internet, and they start with 209.244.03. So these are what we are going to route these things through. Are well-known public IP addresses. If you Google it, you see them. One is .3, the other one is .4. So either 209.244.033, while this one is .4. So the port number here will be 53, the DNS port number. Let me also explain that. So these IP addresses are non-public public DNS servers and form part of layer 3, or mostly referred to as a CenturyLink IP addresses. It happens when you want to really explore IP addresses, you get to know this stuff, this guy. So that's how they work. So we are going to add that rule now. Now we are going to configure a DNS for the server by turning that server into a DNS server. We're going to turn that workload server into DNS. So how do we do that? We go to the VM itself. Under the VM, check the network settings and go to this is the network interface card attached to it. So under this place, No, that's not what I'm supposed to click. Where is network interface card? So Nick is the server networking. So we have okay, this guy. Network interface card is this. So IP or DNS server. So from here, you will make it to be custom. So being custom, we need to still add that same public DNS IP, public IP address, which we specify in the network collection rule, .4 and .3. You need to add them separately. So we have two of them. So here you save them. Not valid. Did I? Okay. Maybe as I copy and paste, there was a gap there. So we save that. This rule is still updating to finish. So we have turned that server into a DNS server as it stands now. So testing our own configuration that we have done so far. Let's go back to the jump VNet, no jump VM. Yeah, we have already logged. Okay, we didn't log into that VM. You can pick the private IP address of the VM of the work VM, which is this guy. Pick it from here. Then go back to the run your remote desktop RDP. But another thing is that, on when you deploy a VM, your internet protocol, that is the IE, security is blocked by default. So you need to disable that protection. So you'll be able to use Internet Explorer. So we'll off this guy. I've also off it in the private, in the workload VM. So yeah, remote desktop, paste the private IP. It's trying to authenticate. Now the name that we define in our bicep file is local, which works across both. The password is copy that and paste. So the password is this. I'll connect to it. So if you observe, which I may mention before, the best practice is that your workload VM shouldn't have a public IP address. Instead, the public IP address that controls access to this guy is pointed to the firewall. Remember, the firewall has a public IP and private IP. So that is how the best practice that will work for you when you're handling. If you observe, we are now in this is the jump VNet, while this particular one here is the private, is the workload, which we are accessing using the private IP address. So now if you open, we need to disable that IE configuration in this workload VM to be able to use Internet Explorer. So go to turn off all this stuff. Now let's give it a shot. Okay, it's disabled now. So open to your this thing, to your Internet Explorer. I'll say don't use that. So yeah, if I type google.com, it will block, deny, no rule match. So you can go on and type any website you want to type, other than the one that was added as the rule, which is bing.com. So if I go to bing.com, you can visit bing.com. Or if I want to say, let's visit the website itself, bing.com, yeah. So we visit bing.com. So now, this is how you can do create rules for a lot of websites that want people to access within that VM under the firewall rule. So yeah, you can add another one. The rules is limited. It's not like, I don't think there's any limitation in the number of rules you can actually define. I think you can have up to 500 rules, or depending on what one. So that is how, if I say, okay, let me add google.com now, another one, app collection 02 200 allowed. Sorry, the priority should be like 100. Let me give it 300. I've already used 200 for the other one. So now I will say this is the name allowed, allow Google. I will put the IP address of that workload subnet with this guy. So I will put it there. I will allow the HTTP AT and HTTPS 443. Then I will now say google.com. Google.com. So that now I'll add it. So the rules will update. If you visit server now and type in google.com, you'll be able to visit that particular website. So do you have any questions? We have come to the end of our demo. Okay, okay. Emmanuel, you can ask.
Yes, sir. Thank you, sir. Please, can you visit the network rule again? Please, can you just throw more light on the network rule, sir? So that we'll...
Okay. Now, network rules allow you to turn your server into a DNS server. By allowing rules, but basically what I did now, I use classic firewall rule. And classic firewall does not allow, Microsoft Azure classic firewall does not allow access to private DNS. They only allow access to a well-known public IP addresses that is globally available on the internet. If you Google this, let me give you the IP address to go and Google it, like 200. Let me go to this guy. If I just type it randomly, okay, let's go to google.com. Put that IP address and read more about it. So the network rule will allow you to route access through DNS port. Remember, as I said before, DNS is like an address book that helps translate. We are saying bing.com. So it means that behind Bing, there's an IP address, which is 209.244.0.3 or .4. So the network rule controls the DNS side of things that helps translate that publicly fully qualified domain name that we define at the application collection rule. Is that clear?
Yes, sir. Very clear, sir.
This operates on level 3 of the OSI model. Is a public public address. You can use it, and no restriction to it. So now we have added another one called what did I do there? I have added another rule now in this place. I think it must have finished updating. Well, take its time. So okay, so to do a recap for our section, let me specifically make us to understand how when to use. I think we understand when to use Azure front door and when to use CDN. If you do not understand, let's ask question now. And another one is that I want to ask a question. Okay, let's assume I have SQL server that my company is operating or user is operating. Do you think I can use Azure Firewall to protect access to my SQL server? Anyone can answer that question? Or do you think I will use our application gateway to protect access to my SQL server? The answer is no. You cannot use it directly to protect. Okay, Emmanuel, you want to share more like that?
No, you can continue, sir. Continue, sir.
You cannot use app gateway to directly protect access to your SQL server. Why? App gateway operate at layer 7. While SQL, I don't know how many of you can tell me the port number for SQL server. SQL. Don't Google it. If you can just tell me, I'll give you voucher. But if you can't, if you waste time to 5 minutes, I know that you Google it. So now the SQL server operate on port number. So it doesn't route through any layer of the SQL of the OSI model. So that is why you cannot directly use app gateway to protect access to your SQL server. Now, another thing is that for firewall now, Azure Firewall now, I have an SQL server now that I want to show, but they force you, they compel you that company policy says that access to SQL server must be through Azure Firewall. Now you need to ask question, if we have SQL PaaS service. SQL is a managed service that it can function as Azure PaaS. When it functions as Azure PaaS, it means that you can protect using app gateway because at that time it's a managed service. But when you operate SQL VM, you can use Azure Firewall. So, but then how can you now then protect your SQL server using Azure Firewall if the policy of the company says you must? So, like as I mentioned before, the take home is that you need to route through what is called an SQL private endpoint. You need to use the private endpoint to protect what's called SQL. That's the managed service. Using, I don't know if that is clear. Can someone recap what I just said or what I said before? I think I made mention of it when I was explaining. So now the summary is that for your app service, you need to have app gateway plus WAF, that is web application firewall, plus private endpoints to achieve firewall protection on your app service. But if you want to use app gateway and WAF for protecting your app service without having to use Azure Firewall, that means app gateway and WAF is enough for you to protect. But in a situation where the policies of the organization says you must use Azure Firewall, that's when you can now have the private endpoint. Now, how do you now protect access to SQL that is under a managed service, a managed SQL? Oh, Busaya, that is not the port number. The port number for SQL is 1433. You omitted one. You just correct. Bayemi has it, but it has passed the time. Meaning you must have Googled it or ChatGPT. So now SQL server, SQL DB, that is not that is not operating on your VM. You can only achieve that by combining private endpoint and NSG and firewall. Then sometime Microsoft, if you look at the Microsoft Defender for Cloud family, we have Defender for SQL. I also put that into consideration. Now, for private endpoint, you need to route the private link. The link is usually a universal link on Azure. It used to be defined as private link dot database.windows.net. You need to point it to the private endpoint for that. So that is just the take-home stuff I needed to explain. So now let's test the second rule and call it a day. The second rule is that we be open rule for google.com to be accessible on this workload VM. So google.com. So Google is non-working. So that's how you can go on and add those sites you want to allow. Okay, thank you very much for your time, and I appreciate for listening. Do have a lovely day. Sorry, I actually stopped sharing my screen. Let me share it again. Don't forget, best practice is that once you're done with your experiment, we will clean up your resources. Otherwise, Microsoft you have to incur costs for disobeying that. So let's just wipe the resource using what's it called, the command here, command line interface. We can't go on and want to delete all those resources. There are many. So we open to this guy. I'll just switch to bash. Now use the CLI command, the AZ group delete. That's the resource group. The name is MS security underscore RG. Then we can add the first command, the deletion, without having to prompt us for yes or no. Oh, I think the delete is not correctly typed. I omitted E there. So it's going to throw an error. So I'm going to just do that again by putting E in this place. AZ grouped delete resource group name MS security dash first. What did he say? Did I make mistake with my typography? Resource group. Oh, sorry. I think this is supposed to be name. None of you pay attention to it. Oh, it's still not deleting. Okay. So let's do like this. Let's run the name, the N alone. But then that's the best practice. So delete your resource and then make sure you are good. So name, false deletion type. Okay. This is double false deletion types. This is another one. Name could not be found. Oh, sorry. This is supposed to be one even. Oh, even the resource group name is wrong. That is why all those stuff it could run an error. So the first command should work. The first command should work. It's just that the resource group name wasn't correct. It's supposed to be this is dash no even instead of this. So it's supposed to work. Okay, so this is how you can delete it. AZ group delete dash false deletion type should be there is a trouble with this command. Okay, so if the command doesn't work, let's just go to resource group, delete it. Wondering why that small command could not work. So, but then just delete it manually from here. No. Apply force delete so it can be faster. Okay, so Emmanuel, thank you very much for having me. I've come to the end of my session.
Yeah, thank you very much, sir. Like your section is really educative and very, very insightful. I've learned a lot. I've learned a lot personally. So the audience in the house, please, let's cheer and celebrate our MVP
Thank
in the
you.
house. Thank you very much, sir. So you can
You're
unmute your
welcome.
mic and
Thank you,
thank
sir.
our MVP.
You're
Thank you very
welcome.
much, sir.
You're
Like
welcome.
this is
Thanks for
one of
joining.
the
Thank you,
best
sir.
sections. Thank you
You're
very much,
welcome.
sir.
Oh, okay. Bye-bye.
Thank you,
Mr.
sir.
Imoh. Mr. Imoh,
Yeah.
long time, sir.
Okay. Yeah, I did. No time. Longest time.
I'll
Yeah.
reach out to you, sir. I'll reach out to
Okay.
you.
Okay. No problem.
Thank you, sir. So
Yeah.
our MVP, Emmanuel Itoje. Well done, sir. I don't know if you have any announcement or you want to say anything before our speaker leaves the call.
Thank you so much, MVP. It's been a pleasure. I hope thank
Ghana.
everyone for joining.
You get MVP over. My boss.
It was an insightful session. Thank you so much. We look forward to having you again in our future sessions to come and deliver as you did today. Thank you so much, everyone. Thank you for joining, and we're going to see you in our next session by next month. Thank you, everyone. Enjoy your weekend. So the recording will be made available on our YouTube channel, and if you have not joined the YouTube WhatsApp community, well, we usually post it. Once the record is available, it will be posted there for us to revisit these sessions and all other sessions. Thank you, everyone, for joining, and enjoy the rest of your weekend. And happy Easter once again.